What's up, everybody? CodePen Radio number 411. I have my friend, co-founder, and CTO of CodePen, the original senior programmer himself, Mr. Alex Vasquez. How you doing, Alex?
Good. Thanks for having me back.
Yeah, always a pleasure, my man. We're gonna talk about some CTO level crap here that's really deep at the heart of CodePen 2.0. And we're gonna use the word TreeSitter because TreeSitter is like a real thing. It's on GitHub. It's a project. It's like this deep fundamental aspect of technology that we're gonna talk about because we're using it in a way in CodePen 2.0 that really that is brand new. So, we were talking before this a little bit. There's like this, it's not a coat of paint on CodePen 2.0. It is a really deep re-architecture of how CodePen works, and we need to start telling the world that like it's a build system in a way that is kind of rethinks what a build system can do and be to build front-end websites. That comes from the mind of you, and TreeSitter is a part of that. But it's like holy cow, does it change this stuff? It's not just a repackaging of Vite or something. It's different than that.
Yeah, it's definitely a very custom, bespoke CodePen like solution that we hope fits the simplicity of CodePen, but with just so much more power. I mean, internally we refer to this version of CodePen as CodePen 2.0, and that feels like a bit of an understatement for what's happened. We're trying to keep the spirit of how simple it is to use CodePen, but give you all the power, and that's not easy.
Right. And part of that power comes from this idea that we need to like understand what you're writing as a developer. We're not asking you to write in a new way. We're not trying to like force you to write HTML, CSS, and JavaScript in some non-standard way mostly. But like if we can like look at the code that you're trying to write and like understand from every detail of it down to the syntax of what you're writing, feel like we can make some choices there and be like, ooh, I see what they're trying to do. We can help with that. Anytime we can help, we want to.
Yeah, I mean, in keeping with the spirit of CodePen, we're trying to create a front-end build system that you don't have to learn, right? The more we learn about what you're doing, because we're purpose-built to build front-end websites, we're hoping that there's not much to learn when you're using our new CodePen experience. And a huge part of that is TreeSitter.
TreeSitter, which is I don't know, we should just say it. We haven't even said it. I think of it as like this I don't know, abstract syntax tree machine, I guess. Is that basically it, kind of?
Yeah, if you think about what TreeSitter is, it's a parser. It turns source code, so structured code, into a structured tree, and it has accurate details about what's in the source code. So you know if a name is a comment, or it's a variable name, or it's just a function or a class or a struct. And what's really unique about TreeSitter is it's agnostic of any one specific language. A lot of the parsers are specific to like Java or JavaScript or PHP, whatever it may be. TreeSitter is odd in that it allows you to write what they call custom grammars for different languages.
The grammar word. So grammar means like, I'm going to show TreeSitter this grammar, and now TreeSitter is going to like better understand what HTML is. So we get like a good AST of HTML, but it doesn't have to be just HTML. It could be whatever.
Yeah, like whenever you can have, if you have like custom domain specific language code, like CodePen has some of that with our little triple bracket solution that we have for embedding HTML inside of our pens. We wrote a little custom grammar that can pick up on those things, and TreeSitter is really unique in what it's purpose built for. It's built to be used while someone's editing code, and that's a really unique requirement for the kind of parser we're looking for, because while someone's editing code, if you're parsing their source code, one of the number one things you need to do is be super duper fast. And TreeSitter is super duper fast. It's written in C. It's extremely fast, and we have the ability to call it as just a regular library from our Golang source code.
Yeah, I thought of it as a Go thing, but it's not, right? Is it? It's you're saying it's just C mostly?
Yeah, it's actually the actual core. I'm pretty sure that it's most of it is written in C. Maybe a portion of it is written in Rust, but at the end of the day, it's written in something that compiles down to a generic binary that you can link to. And so we use the C bindings in Go to call TreeSitter as like a library. So it can be used from JavaScript and other languages that need it, like Python and things like that. So it's like the same library, but it's used by multiple other languages because of the way it's built.
So it's the way you call it is like it's step one on this multi-step solution of like understanding what is all happening here in this pen, which is a collection of files to process. And TreeSitter is fundamental in getting us the information that we need. And then once we have the information, then we can craft a plan of how to build it together. So what we might get out of TreeSitter is like, ooh, this file has like stuff in it that's linking to or depends on these other files, and that file has dependencies on these other files. We're like understanding how everything is linked together, how you want it to be, and what languages are being used that we need to deconstruct and do work with. And all that is like, we get that information through TreeSitter. Like we need it.
Right. Yeah. So we have this custom build system that wants to learn what your purpose is, not by you writing a custom build plan or like some custom config doc where you tell us what should happen first, second, third, and fifth. I think I skipped fourth there. Sorry about that. Fourth and fifth. And so anyways, but we're trying to figure that out based on your source code, because CodePen is only built for front end. That's all we care about. It's all we're going to be focusing on for as long as we exist. And so step one, before we can figure out what to do and what to build first, second, and third, we have to parse the source code. And not only do we have to parse the source code, we have to figure out like if an import is an import. Like say you have a JavaScript file and you're importing another file, we need to know like, is that a third party import? Should that come from NPM, or should that come from just another file has the same name that's relative to your file system, whatever it may be? And so
thanks to TreeSitter, it's trivial to understand that difference, right? I mean, I don't want to call it trivial, but a little bit.
I mean, honestly, the kind of work it would take to implement TreeSitter, we can call it trivial. What we have to do, our work, our end of the bargain, is very trivial in comparison to writing a custom parser that would accurately handle the issues that TreeSitter handles. And that's where, when we were looking to choose a solution, this was something that like really, I was honestly dead set on building my own parser, because I was like, how hard could it be? How hard could it be to build your own parser for X number of languages, right? Because we're not looking for, TreeSitter can be used for so many things, but a lot of times, like if you look at how it's used in GitHub, they use it to identify every portion of source code. So they need to know variables, function names, how they're linked, what library they come from, what class, all these things. We need much less information for our build system to work. And that's great. So initially, there was a big question, like with every project. This is a massive architectural decision we're making. Do you build it or do you buy it? And when we say buy it, we mean
use open source.
Use open source. Free
Unless it's really cheap.
Yeah. And so, we do buy some things, but these things are almost never.
Okay, I didn't realize you had to weigh this so much. I thought it was a little bit more clear of a decision. Or maybe it was clear once you tried TreeSitter.
It was clear. And it was honestly, looking back, it was a very scary decision for me, because there are a myriad of other like parsers. There are things that generate parsers. I think like AntLR and things like that. There are languages dedicated to creating parsers. There are open source Go native libraries, and that was like another big option. And then there's TreeSitter, and TreeSitter is unique because it's used by so many things. There's I forget the name of the Vim editor, but there's a Vim editor that uses TreeSitter to parse code. It's used in a ton of different scenarios, but importantly, it's used by GitHub. And I think at this point, it's used by the Z editor, the person.
I was going to bring that up too, because the z.dev is the URL. It's called the Z editor. It's actually pretty darn good, I think. And it's interesting to have, make VS Code run for its money. Jeepers, come on, And I think some of the people that work on it, or at least one guy, was like the TreeSitter guy. He wrote TreeSitter.
Yeah, the person who developed TreeSitter originally definitely one of the founders of Zed, and we deeply appreciate your work, by the way. It's honestly an amazing library. And so, it's funny looking back now. It was such a scary decision because I didn't want to make a bad decision. I wanted to have complete control. And like any decently complex solution that's open source, the big question is how deep is the learning curve? Is it going to fit the scenario that you're looking is it going to solve the problems you're looking to solve? And the beautiful part is it's literally purpose built for what we're doing, where you have to parse code that is changing very quickly and can have significant syntax errors because the user's in the middle of writing the code, right? And that's something that's really unique about our problem set. Like if you're writing a code editor and someone's in the middle of a function name, they could completely blow up a regular parser because it's like, hey, your syntax is incorrect.
Yeah, it's going to look like garbage, and a poorly written processor will look at it and be like, oh, warning, disaster has struck. Yeah, you've taught me this about TreeSitter. The TreeSitter is like way more chill about it.
Yeah, it uses a technology called an LR parser, which he did not invent, but he definitely made incredible use of, where it has the ability to understand that there's an error in a section of the code, mark that code as errored due to this incorrect syntax, but then continue parsing the rest of the code, right? So if you're a programmer, you're editing one specific function name, but then all the functions below that function are correct and all the source code is correct because, hey, I'm just in the middle of editing this one file. Mm-hmm. TreeSitter won't blow up. It won't like explode and give you no information about what it parsed. TreeSitter will recover from that error and then continue parsing and give you accurate information about everything that's below it and above the errored syntax. And for our use case, that is magical. I don't know how long it would have taken me to get to that point. I probably would have ended up writing an LR parser.
Yeah.
And attempting to recreate in a very basic budget level way exactly what TreeSitter is doing, but in our native Golang. So I honestly think nowadays I think of TreeSitter as like the second best architectural technology decision I've ever made, second to choosing Golang as a language that we rely on. I absolutely love it.
Pretty huge,
Yeah.
We've made a number of good choices, I hope,
Yeah, I hope. Time will tell.
Some of them are less clear. Like we use Next, and I feel like, gosh, this was good. Like we were really productive with it, and we have good componentry, and I think our front end is very organized and useful, and it's like never like we move fairly quickly with it and stuff. But I'm like a little less sure that it was like, absolutely genius. Like maybe we'd feel that same way if we used something else. I don't know. But in this case, there's nothing to look at and like maybe the grass was greener over in some other parser town. Like I don't think we ever think that way about this choice.
No, not at all. It's I can't imagine going back. There are some drawbacks to TreeSitter, and I think probably it's a good time to talk a little bit about that. I think the learning curve is, I would describe it as short but steep initially, right? So I think after 2 to 3 months of using it regularly, I felt pretty comfortable with it, but there was definitely some doubt that I had initially because I didn't understand it. TreeSitter is its own little ecosystem, and it has its own, what I would describe as a domain specific language for how to get information out of the abstract syntax tree that it creates. It uses a query language that it's called S expressions, is kind of what you submit to it. And if you've never written in a programming language like Lisp or Clojure, that is very foreign and very alien.
I don't even know what they look like. An S expression?
Yeah, it's essentially a bunch of parentheses around.
So this is not a grammar. You already got your grammar. TreeSitters run it through this grammar, but now you're like, I need to ask TreeSitter, like, give me something. An S expression is how you ask it.
Yeah, so like essentially like a grammar defines what the source code structure is going to look like according to the language spec. But then when you need to query that source code and ask TreeSitter to tell you what's in there, you submit a query in the format of S expressions, which is it's also a tree-like structure because you see so many parentheses, the way things are designed, right? Like there's a root query and then you keep submitting subsequent queries. So like imagine braces, instead of using braces, you use parens everywhere. And that sounds like such a simple little shift in your brain. Like most programmers who do JavaScript and TypeScript and things like that, they're used to seeing, your eyes automatically see the structure when there's braces everywhere, right? So if you have like a nested if statement and a while statement in there and whatever, you can nest it almost infinitely. And most programmers, you can just see that because that's what your eyes are used to. TreeSitter uses S expression, which shifts it does a lot more than that, but it's mostly what you initially will see is a bunch of parentheses and it looks like gobbledygook to your eyes. So there's an adjustment period where you can't recognize where something begins and ends. And the first thing I had to do was I wrote a formatter that formats S expressions for the abstract syntax.
Really? Like it adds line breaks and stuff to help you?
Yeah, imagine like prettier, but for an S expression. Like I just wrote it internally.
Amazing.
And it honestly was like, once I think I almost feel like the act of having to write that formatter made it easier to understand what the S expression was doing.
Yeah. How could it not? You have to understand what they are in order to write that thing. Yeah, that's amazing.
Yeah, and what's interesting is that's what I hated about TreeSitter. If you ask me, what do you love today, like 2 or 3 years on of using TreeSitter, is I love using S expression.
What?
Yeah, because it puts you in the mindset of like, I'm now querying this TreeSitter tree, and it's very easy to get into because I can recognize it. My eyes can just see it. I can jump back into it and see like, okay, this is what the tree looks like. This is what my query should look like. You just learn to connect. And because it's its own little ecosystem, it's almost easy to recall because it's its own little language that you're using to use TreeSitter.
Yeah, I can see that. So that's the love-hate relationship people have with domain-specific languages, right? Is that like a little too much lock-in sometimes. You wish it was more reusable knowledge, but it's probably that way for a good reason. That it's like it's the perfect solution for the problem at hand.
Yeah, and at the very least, it's it's its own little domain of ideas and knowledge that your mind can immediately jump back into, and it's very funny to see that come full circle. So, depending on how much investment time you have to invest, for us, this is a massive decision. This is not like a little bit. We didn't sprinkle in TreeSitter. It's not something like, I can imagine not liking TreeSitter if I need to use it for kind of like a one-off task. If that were the case, if I just need to know like, hey, I just need to parse CSS once in a while, it's not that significant. I probably would have just written some Golang or used a Golang library for parsing CSS, or God forbid, do what we've done our entire career at CodePen, which is use regex. But I've always said, if you think regex is going to solve your problems, you've got more problems. Because inevitably regex will go sideways on you because you have, especially when you're parsing source code.
Well, that's what I was going to bring up is like one of the jobs we need that I already kind of mentioned is I need you to look at this piece of code and I need you to find places where it links to other code. That would be an S expression that you need to write. Like, I need them all because I need to make some choices and decisions here, and know where to look next and stuff. So there's, I don't know, I imagine there's not my purview, but there's probably an X expression that does that we have. And then
absolutely,
yeah. Where was I going with that? But does that? I don't know. What does that look like? That was trivial to do, or it depends on the language?
It's trivial now. Like, we now have the ability to parse any language, and we have. So, for example, one of the languages CodePen supports is nunjucks. There is no specific great solution for nunjucks, but there.
Like, somebody
Python,
could write a great grammar, but there doesn't exist one. I remember this conversation because you're like, but HTML is so close that it just doesn't matter. You just use that one.
Well, yeah, but specifically for nunjucks, there was something we needed.
That's right. The weird include syntax.
Yeah, the include syntax is unique, and you can't just pick up on it using HTML. But there is a very similar language called Jinja in the Python ecosystem, and there is a grammar for that I was able to use to find just the information that I needed. So it's not perfect, but because we don't need to know absolutely every detail of the source code, right? We are not writing a code that parses nunjucks and then creates HTML, right? We're leaving that to nunjucks. But we do need to know how one nunjucks file connects to another, and we need to have certainty over that. That's how we can kind of get by with these grammars, and I adapt them and customize them when I need to. Like, we have a fork of the Go library that the kind of like canonical Go TreeSitter bindings, which is provided by a open source user on GitHub named Smacker. And that's been excellent, but that's extensible. And so we kind of keep our own fork of that and then pull from his main branch when we need updates.
Yeah. So what do you call that when you figure out the whole like tree of how a project is organized, but just by looking at the source code that we have? Because we need to like figure it out programmatically. You could just like look and be like, wow, they have some files and some folders and stuff. But whatever a user's file system is like not the source of truth over what is actually used and what links to what and all that. So there might be unused files and subtrees and whatever, but you kind of create a understanding of that, right?
Right. So, the first thing we do is scan and parse the file system, right? We'll save your code to a file system, scan and parse it. And then after that, we're going to create our own kind of internal abstract syntax tree, and we represent it as a graph internally.
Yeah,
right?
graph, right.
Yeah, so we have a graph of many pieces we have multiple graphs and multiple representations of your code. And that allows us to determine, like, okay, is this what I would call an entry point, right? An entry point is like an HTML file is an entry point because that can be served to a web browser and rendered. If you import a JavaScript file into an HTML file, that is considered an entry point because that JavaScript file is linked to directly and then thus served to the
right.
browser.
It's not all
well.
intra-language; it's cross languages, right?
Right, but that JavaScript file may import other JavaScript files. Those other JavaScript files are more like library imports, right? And so, like any decent graph, it would officially be called a directed acyclic graph, right? Which is just like a graph that looks like a tree. and it should not have any cycles in it, but sometimes it does.
Well, I like the tree metaphor because, to connect this to our users a little bit, let's say we got this whole graph of your system or a tree or whatever. There's a leaf of a tree. A leaf is often thought of as like the last thing. Like there's nothing after the leaf. The leaf is as far out down the tree as you can get. And our system also says like, oh, that leaf is SAS. That file ends in .scss. We know we can relatively safely process that thing down into CSS because nothing else depends on it. Then we can move up the graph a little bit. If that thing is also SAS, then now we can safely process that one. That's what I mean about this like intelligently created build process thing. That's one of the fundamental like powers of this new system that Alex has cooked up, is that by the time it's like higher up the tree to the trunk of the tree or whatever, everything, all these like languages are already processed down to their primitive language that the browser already understands, and that you don't have to configure tools to like understand how it should process TypeScript. Don't worry about it. Our system has already turned that TypeScript into JavaScript, and you don't need to concern yourself about how to combine tools together, because our tool has already primitized all this stuff. It is a new approach to how this stuff is built. So sorry, don't steal our idea. Patent pending.
Or do, and we'll see you in a couple of years. That's totally fine with me. It's interesting because the way our goal has been to write a build system you don't have to learn, where the build system is helping you and you don't have to configure it and connect it. We are doing our best to try to automatically understand what you're doing. And because we are specific to the web, there's a very specific way that we build. And when I say we, I mean humanity at large, the royal we, builds websites. You always, if you have an HTML file that links to TypeScript and SAS, you know that you need to process TypeScript and SAS before you then link
and don't worry about telling us. Just make a file called .ts. We got you. We'll figure it out. Don't even worry about it,
If there's one thing CodePen understands, it's front-end code and what to do with it, right? We build help people build a lot of web pages.
Well, and we have some education to do to teach people to not worry about it. Like, I don't want to be opaque too, because we're trying to actually be very like explain what and show you what we are doing too. It's not like a secret system. But some people are like, oh, I want to use TypeScript, but I'm using it in 11D or whatever. Not that I don't know if that will be a launch block for us or not, but it's one of those things where you're like, okay, now there's like, it's in people's heads. They're like, well, I need to figure out how those two technologies go together. I probably need to like look at some docs to figure out like how it wants me to deal with that, or parse together my own little build system that like deals with this other language I need before it gets to 11 or something, and we're like, don't worry about it. We will make it work for you. Don't worry about how multiple technologies interleave and figure each other out, because like straight up talking to developers, they hate it. It's so common to hear somebody, they literally have a term for it. It's called config hell. And it's not that we don't like config. We want to offer you config, but I don't want you to worry about how config goes together. Like you worry about an individual
That's where the complexity comes in, right?
Yeah.
It's, when you're just looking at configuring something to, for example, process TypeScript, that's simple. When you're looking at something to like process SAS or process stylus, that's pretty simple. Is any typical experienced developer can figure that out. What becomes hard is when you go, I want to use Next and I want to use stylus, but then I want to import this library and I want to use this version of TypeScript with this other library. That becomes really complicated very quickly, because combining the technologies adds a lot of complexity to the things that we do. And we're trying to minimize that complexity. We're trying to kind of put a ceiling on how complex that can be. And we get to find out hopefully pretty soon. We get to find out if we've achieved that. We've been working pretty hard to make that happen, and I can't wait to figure that out. But that's a critical piece of what we use TreeSitter for, to figure out how are these things linked and how do we combine them so we can build you a beautiful website.
Yeah, it's the root of that information. You don't have to tell us. We'll figure it out. And there's no way we could figure it out without TreeSitter.
Yeah, absolutely not. It would take us a lot longer than we've taken just to build this thing. So we absolutely love the solution. if it's something you're considering, I would not hesitate to opt into TreeSitter.
Yeah, that's good to know. So maybe we end it like as a, let's say a user, we call this like stop typing, or at least that's what I come up with in my mind. That there's this fundamental UX thing of what CodePen is code, stop and think for a second. We're like, got you. I'm going to run this. If I can possibly run this and show you what the code you've done so far is, we're going to do that. You don't have to hit a button to do it. There's a setting to turn that off if you want, but for the most part, it's like type, stop, see what happens. That's fundamental to CodePen. Now, the old editor was like just primitive. It's just like, I don't know, I guess I'll run these technologies. But now we have a whole file system. It's a lot more complicated. What happens now in a stop typing event, Alex? Like what,
Yeah.
when a build starts?
Yeah. As soon as the build starts, we transfer over the files that you've updated, and we have your access to your source code. We're going to represent your source code in the browser as a true file system. That's when we get to parse the source code, figure out how things are linked, and then we start kind of, I would call it, it's called a build system, but you really are massaging the source code to make sure that things are linked correctly. We're validating that certain attributes are there, right? We want to make sure that your website will not only build, but that it'll be functional. And we're trying to be helpful when we have the certainty that we know we're being helpful. We're not being obnoxious. That's kind of a very, that tends to be a bit of a gray area where we need to determine how helpful can we be, and are we being helpful? Is there any chance that we're going to be obnoxious and annoy you while you're editing your code? Because we still want to get out of your way. That's kind of the whole point. And so once we're writing your source code to the file system, we parse it, we determine what we create, something internally we call a build plan, which determines what gets built first, second, third, fourth, and fifth. We're going to run through that build plan, create your website, and serve it up to you. That's the build system in a nutshell. It sounds really simple. I wish it were so. The devil's in the details, like with any build system. But because we know that we're only dealing with front-end code, we know almost 100% of the time what should come first, second, and third. We know that, if you have a SAS file, but you're also using a technology like Tailwind, we probably should process your SAS first, then run Tailwind, then link it to your HTML. Those little details are important so that you, the end user, don't have to think about any of it, right? Like we want you to focus on the code. We'll focus on combining the technology. We want to give you that like beautiful feedback loop where all you're thinking about is what should I build next? Not how do I configure these technologies that like I really love, but they're so cumbersome and they're so finicky and they break in weird ways. That's kind of what we're trying to build here. So
it sounds like a little, but I was almost like, you don't even know how much happens after a stop typing event. I mean, but it's like, it's fascinating to me how it's like, well, we have every single file in your entire project and we really quickly like have them on disk and understand them and parse through them and make this entire abstract syntax tree, which turns into a graph, which turns into a build plan, which executes the build plan, and it calls all these internal processors to execute that build plan, makes basically a dist folder, returns the dist folder, but it does it all efficiently with caching and low network request stuff, and then displays you that website, and it does it in like a couple of milliseconds. And then you type background green instead of background red, and it does it all over again.
It does it every single time.
But it has a lot of work to do, but we had it doesn't have a local computer to do it on. We do it for you on big fancy frickin' servers in the cloud, because server stuff is part of our expertise. It's just amazing to me knowing, like, I was nervous, like how much work it has to do each time. Like, can we do this fast enough to be a web app? And it's like, apparently we can, which is shocking to me how much, But
that's honestly where some of the tech choices we made, I'm really happy with, to go from time estimates that we had before where we were writing everything in Ruby. I love Ruby. I love Ruby on Rails. But attempting to do any of this in Ruby would be a bit of a nightmare because it's just the speed is just not there. And maybe there's a Ruby expert that can get Ruby to do it at the speed that we would need it. I'm not that expert. What I really love about using a technology like Go is that I don't have to be clever. I can just be very clear and almost naive to the implementation. The code is easier to understand because we're not trying to be clever. The speed is baked into the language.
I know you bring that up a lot where you're like, when we're pleased with the performance or whatever, or starting to worry about whatever we're feeling about it, you're like, you realize we haven't even started to optimize.
We literally haven't even started optimizing the speed. Like it's wild at times. We recently updated to the latest version of Go 1.25 and dropped our CPU usage from like 5% to like 2.5%. Just nothing. We did nothing. And so I'd much rather appear clever externally and not be very smart than to attempt to be clever internally and not appear very smart because our system is slow. So TreeSitter is this massive tool in our ability to seem like we're way smarter than we are because we're using the right tools for the right job, and it's been spectacular for that.
Amazing. Well, thanks for talking to me about this. It probably won't be the last time as we get into more of explaining about this. It was so tempting to talk about more of the why and how CodePen 2.0 works, but now the cat's out of the bag. This is the first time we've really got into to how it works, and I think people will be surprised at how many problems we can solve with this system and just how different it really is without feeling foreign or weird.
Yeah, that's always been the dance for us, right? It's like, how do we keep the simplicity of CodePen and yet allow users to do what they want to do with complete websites? And that's a really hard problem.
It is, and it's both front end and back end. You know, we've taken some steps even just recently to just really make sure that nobody's like too annoyed at the cheese moving. You know, like if they want it to be like it was before, I don't want you to be annoyed necessarily. Partially a business decision of like, I don't know, I don't want to lose people for something silly. But there's certain times where you need to be like, but you're gonna need to like. It behooves you to learn some of this new system, right? There's a lot of power here. And if you're like totally unwilling to learn any of that, like I'm not that worried about, we're making a new thing here. And I guess we'll catch you when you're ready for that. But at the same time, it's like, we can probably do better though, you know? So there's a lot of steps. We have a thing we haven't talked about that much called the classic block that kind of processes things like the old one did. The UI can be made to look very, very, very similar to the old editor. It's pretty similar, but then the power's there if you want it. The second you want more than that, the second you have this feeling like, why can't I have a second HTML file? You don't have to think that anymore. You do have it, and not only that, but there's just a world of opportunity underneath all that for you.
Yep. And we've taken great pains to annoy ourselves and not you as much, but I can tell you that every time you make those design decisions where you take it on yourself to take on the complexity, it can be really tough, and you question whether or not it's valuable enough. But I feel like we've always made that decision to take on the complexity and on behalf of the user instead of just exporting it to them. And I'm extremely happy with the end result. So we'll see. I can't wait to get feedback from everybody when you're using it.
Yeah. Cheers. All right. Thanks, man. See you again.
Bye.